So now we're going to talk about how to write formulas from names. And again, each different type of compound has a different way of doing this. Again, I think ionic is a little bit more complicated than the rest, but we're going to start with ionic. So the way you write formulas for ionic compounds is it's something called the crisscross method, because ionic formulas are all about the charges. Remember that ionic compounds, the overall charge needs to equal 0, so the charges need to equal out. So the first thing you're going to do very simply, like for 21, is I'm just going to write the symbol. So I know sodium is Na, and phosphide, remember if it has an IDE ending, you know it's just the regular phosphorus, not the polyatomic, because a polyatomic always has an 8 or an I ending. So I write the symbols, and then I'm going to write the charge. Remember, the charge is written at the top of your periodic table. So I see that Na is in column 1A, so its charge is +1. And again, phosphorus is in column 5A, so its charge is -3. And what you're going to do is something called the crisscross method. In the crisscross method, you rewrite the symbols closer together, leaving a little space, and you crisscross the charges, meaning the charge of one element becomes the subscript of the other element. So if we look here, the Na +1 is going to go and become the subscript of P, and you don't write a 1. And then the -3 of P is going to become the subscript of Na. So your formula is going to be Na3P. The charge becomes the subscript. Obviously, you don't bring down the actual plus or minus, and it becomes a subscript, so you write it lower, but the charge becomes the subscript. You don't write subscripts of 1, you would just leave that blank. And what's going to happen here is the charges actually are going to balance out. So if you actually look at this formula, remember that Na is a charge of +1, phosphorus is a charge of -3. So if you say, okay, there's 3 Nas, each with a charge of +1, that's going to give me a total charge of +3. And then 1 phosphorus is going to have a total charge of -3. Well, that equals 0. And what's going to happen is that's going to happen every time. It's just going to balance out like that. The one thing you do have to check is that your subscripts are in their simplest form, just like in math. They have to be in the simplest ratio. In this case, you have a 1, so obviously it's in the simplest ratio. Now this next one, the first part's the same. I'm going to have calcium. It's in column 2A, so its charge is +2. Now for this second one, ATE ending immediately tells me it is not phosphorus like in 21, it's phosphate. It's the polyatomic. You got to find it from the chart. So I'm going to go on my chart and I'm going to find that phosphate is PO4 and its charge is -3. It's phosphate, not phosphide. Again, everything else is the same. You use the crisscross method, the charge becomes the subscript. So Ca is now going to have a subscript of 3, which comes from the phosphate. And then the phosphate is going to have a subscript of 2. Now here's the problem with that. If you look on the phosphate, you could not, I'm just going to erase this so I have some room here. You can't do it like this. So if you want to add a subscript to a phosphate, I can't do that, because that changes the ratio. That's all of a sudden PO42. That's not good. So what you have to do when you write charges on polyatomics is you have to put parentheses around them and put the subscript on the outside. Because you can all see there's a big difference between PO42 and PO4 with 2 on the outside of the parentheses. So the formula for calcium phosphate is going to be Ca3PO4 2. Remember, the subscripts have to be simplified. They are 3 and 2. This 4 in the phosphate never changes. The way that the polyatomic is written on your chart, on your paper, can never, ever change. You can only add subscripts to the outside. And then finally, the other thing you will see very quickly, so if we see copper is Cu, and that's one of the ones where it has more than one charge. So how do you know which charge to use? Well, our friend right here tells us that it's +1. So for the D block, for the ones in the dungeon, the charge is going to be indicated by the Roman numerals. And then arsenide, again, IDE is arsenic, AS. And arsenic is in group 5A, so its charge is -3. Remember crisscross, charge becomes the subscript. So the copper is going to have the 3 from the arsenic as a subscript. The arsenic is going to have a 1, which is not written. So the formula is Cu3As. And again, that's simplified, so we don't have to do anything else. Next, we're going to look at the formulas for covalent compounds. And again, I think you're going to find these easier. You don't have to use the crisscross method. What you're going to look at for these is you're going to look at these prefixes here. So you see these prefixes, they're going to tell you what the subscript is. And the big difference between ionic and covalent is you do not simplify covalent. You write it exactly how it's written with the prefixes. So I'm going to find the symbols. Carbon symbol, obviously, you guys know is C. It has nothing written on it. There is no prefix. That's because it's mono, but you don't start with mono. Mono is 1, which you wouldn't write as a subscript. And then oxide is oxygen, and the prefix di tells me it's 2. So carbon dioxide is CO2. We go to the next one. Dinitrogen. The element symbol is for nitrogen N. The prefix di tells me it's N2. And then tetroxide. Oxide symbol is oxygen O. And tetra is 4. So you can see it's just kind of right as it says. You write the symbol and you write the subscript depending on the prefix. Last one, sulfur, which is spelled wrong, I apologize, is just an S. The prefix is 1 because there's nothing there. And then hexachloride. Chloride is chlorine. Hexa is going to be 6. So it's just SCl6. Remember, for covalent compounds, you don't simplify. You just leave the subscripts exactly how they're written according to the prefixes. And finally, for acids. Acids are a lot like ionics in that you're going to use the charge. The one key with an acid, though, is you have to remember, and characteristic of an acid is that they all start with an H+. So the first element for every single acid is going to be an H. Now, the good thing is it's H+, plus 1. So it's very easy to figure out what the subscripts are. So what you're going to do is this. Again, no O hydro. If it does not start with hydro, you know you're going to use the polyatomic form. If it starts with hydro, you're just going to do the single element form. So in 96, it does not have a hydro. So that tells me it is not sulfur, S, it is sulfate, SO4. And again, the ending ic tells me it's 8, not ite. I look up the charge of sulfate, which is -2, and this is how it turns into ionic. Again, the crisscross method. The charge becomes the subscript. So the H is going to get the 2. The SO4 is just going to have a subscript of 1, which you leave. So the formula is H2SO4. One hint, the H is always going to have the subscript. You're never going to add to the second element. Now for 100, that's a little different because it starts with hydro. So hydrofluoric tells me it's fluorine, F, not the polyatomic. So fluorine, fluoric, is just the regular F. You're going to look up the charge is -1. And very simply, if it's -1, +1, all the subscripts are just 1. So it's just HF. And then finally, phosphorus acid. Again, no O. It's going to be the polyatomic. It's going to be the polyatomic PO3 because phosphate is PO4. The 8 would have the ic ending. This has an OUS ending, which has to be the ite, ITE ending. And PO3's charge is -3. Charge becomes the subscript, so the formula there is just H3PO3. Notice I never added anything to the one at the end, the anion or the polyatomic. It's always going to be added to the H, which makes the subscripts easier. And that is how you write the formulas.